Mr. Investor Lot, welcome back to the channel, baby. Today we're going to be talking about Bionano Genomics doing movements in France, securing another contract for Bionano Genomics consumables, interest in Italy for Bionano Genomics optical genome mapping, as well as another article that came out, and Jian Loring, a stem cell scientist, talking about how useful Bionano Genomics optical genome mapping is in terms of capturing structural changes in the genomes. She thinks it will replace karyotyping. Now, please remember, none of this is financial advice, for entertainment only. Hit the thumbs up, hit the subscribe button. You can click join as well to support the channel. It's only 99 cents and it really helps out by supporting the channel. Thank you so much to all the channel members and everybody that supports the content we create right here. Okay, bingo cowboys. When Cisco Trader posted this, he was showing that in France, the Cochin Institute had secured a contract for $400,000 nearly in Bionano Genomics optical genome mapping equipment. This particular place is called INSERM Dr. Paris IDF Center Nords. INSERM is the National Institute of Health and Medical Research. INSERM. It has research facilities throughout France. Having a little look at the fact sheet that they published in 2021, they said this is INSERM at a glance. Founded in 1964, it is dedicated to biomedical research and human health, and it's involved in an entire range of activities from the laboratory to the patient's bedside. So in terms of some statistics, let's take a look here. More than 13,976 publications in 2021 alone. Scientific publications. 42% of the publications in biological and medical fields. They're always securing the patents. They have more than 2,100 active patent families in 2021. Let's take a look at their locations. 2 international mixed units, 3 foreign laboratories with theme-based coordination, 22 foreign laboratories within an international research project or international research network. They've also had some Nobel Prizes and Lasker Prizes under their belt. They employ a lot of people and they've got a mixed budget. 40% is external resources, 60% is state funded, and their initial budget for 2021 was 1.1 billion euros. Now, looking at this, we can see here that their main activity is research, and looking towards the short description, the money is going towards the supply of Bionano genomic reagents and consumables. So they must already have a sapphire. They're purchasing a lot of consumables. Cisco said he believes it looks like it's for a specific project or trial. What do you think they're researching at the moment? Let me know. Drop me some comments down below. On September the 8th, this was posted on Twitter by Esther. She said that Bionano Genomics is at the meeting of Italian Society of Human Genetics, SIGU, with our partner in Italy, Voden Medical. There's growing interest for OGM in this beautiful country, and I think it says their identification of structural variants of the genome. I'm not Italian, but that sounds wonderful. Yep, I was nearly right. Automatic identification of structural variants of the genome. Shout out to Canalope. Over on LinkedIn, a stem cell scientist going by the name of Jian Loring has said that this paper that just came out using Bionano Genomics optical genome mapping to capture structural changes in the genomes of iPSCs, I think it will replace karyotyping. iPSCs are induced pluripotent stem cells, and she said they have a pesky habit of acquiring genomic aberrations in culture. When BNGO announced the publication, they were talking about how useful optical genome mapping is in the workflow of identifying these kind of genomic aberrations in iPSCs. The study that came out provided scientific and practical support for OGM's ability to detect these cryptic and balanced structural variants in CRISPR edited cells, which were not detected by karyotyping, some of which weren't. So often when you get donations of tissue or you get, stem cell therapy and stuff, you can face the body rejecting it due to immune rejection caused by mismatches of human leukocyte antigens, HLAs, between the donor and recipient. So imagine you've been waiting on the donor list for a while for a tissue or organ transplant. All of a sudden you're a match, they put it into the body and the body rejects it. Reading through this, the researchers were using whole genome sequencing, karyotyping, and OGM. Not only did OGM match the karyotype and genome sequence findings of deletions and translocations, and they identified complicated genomic rearrangements missed by other methods, OGM was also able to detect distinctive mutations in those iPSCs that researchers could then avoid using. This means less rejection. Eric Coleman then stated how useful this is, to see research that demonstrates optical genome mapping's utility in the field of regenerative medicine. So let's take a look at that. Regenerative medicine focused around developing and applying new treatments to heal tissues and organs and restore function lost due to aging, disease, and damage or defects. This market in 2020 was valued at $10.1 billion according to Biospace, and is estimated to reach $83.1 billion by 2030, growing at a compounded annual growth rate of 23.6% between 2021 and 2030. So if we look at the brief summary, they've said here, regenerative medicine is an emerging field that aims to repair and replace damaged organs and tissues. It has the potential for treatment of chronic diseases and disorders such as Alzheimer's disease, diabetes, and others. As described by Jian Loring, the stem cell scientist, someone who is active in the field, she said that she thinks it will replace karyotyping. So all the research is kind of providing support and proof that, optical genome mapping is very useful in lots of different places, in lots of different fields, and it can replace the current workflow in terms of these old, outdated, traditional methods used in cytogenomics. Some of you guys asked me about Biden's moonshot for cancer. I think definitely he should include, funding for bionanogenomics for research, especially since bionanogenomics is targeting, the field of cancer and rare disease. He's appointed his choice to lead, the Advanced Research Projects Agency for Health, Dr. Renee Wagrzyn. I can't pronounce her name, forgive me, Renee, but she is the VP of Business Development for BNGO Bioworks. This is a company we looked at a while back, and not only is she the VP of Business Development for BNGO Bioworks, she's also an advisor for the Scientific Advisory Boards at the Innovative Genomics Institute. If they really want to target and kind of fight cancer and other diseases, they're going to put some money into bionanogenomics. If they want to drive biomedical innovation. Over in the UK, I think this was last year or early on in the year, this was one of the projects, one of the guys that got funded over here. He wants to improve diagnosis in hereditary neurodegenerative diseases. He only got a fund of about £48,000, and he was exploring optical genome mapping. He wanted to assess its efficiency in diagnosing the most common neurogenetic diseases, such as front temporal dementia, ALS, nerve damage, and muscular dystrophies, which can be missed by next generation sequencing. So there are grants going about in the US, across Europe, in the UK. When the founder of Bionanogenomics, he actually wanted to use it to look at cancer, so it was created for the purpose of looking at cancer to better understand BRCA1 and BRCA2. As mentioned here in one of our LinkedIn messages, I was asking him about, Bionanogenomics, the history and what it was useful for, and why he created Bionanogenomics in the first place. And he said his very first National Institute of Health grant was to map the BCR/ABL and the BRCA gene, CNV copy number variant, and complex changes. He founded Bionanogenomics because he wanted to see the genome and what and where went wrong directly, and how genome functions and biology is happening with his eyes. With the goals set by President Biden, he said that with his cancer moonshot, he highlighted that he wanted to reduce cancer death rate by half within 25 years and improve the lives of people with cancer and cancer survivors, especially the more aggressive forms of cancer like leukemia, which is currently what they're looking at, blood cancers. The sooner they get diagnosed, the higher the chance of survival. There's literally so much data that's been coming out over the last few years of bionanogenomics, talking about the evaluation of optical genome mapping in a variety of blood cancers, demonstrating high concordance with traditional methods, but also having time and cost advantages and potential for discovery of novel therapeutic targets. Optical genome mapping is faster and more cost effective than traditional techniques used for analyzing acute lymphoblastic leukemia, ALL. So saving time, saving money, saving lives. So someone needs to speak to Rennie over here, sweeten her up, and get some of that money for bionanogenomics, some of that research, money, and grants. Lastly, I wanted to remind you about this. It's been over a year now since the key sites in the UK have adopted Sapphire system for optical genome mapping. Again, Dr. Anwar Al-Haq, the lead clinical scientist and deputy clinical director for NHS Haematology and Pathology at King's College Hospital in London, has said that, faster identification of structural variants is vital for providing diagnostic, prognostic, and treatment decisions for blood cancers. At that time, they were undertaking a pilot validation study of the Sapphire system to produce a single automated cytogenetic workflow to save them time, to save them money, to have quicker turnaround times with better defined structural variant data. And they were hoping ultimately to replace the need for a wide range of cytogenetic methods, just have the Sapphire system in place. This is similar to what Dr. Shirley Hegarty, a consultant clinical scientist at NHS Regional Genetics Laboratory, this is in Belfast City Hospital. Dr. Shirley said that when they were evaluating their options for the future, what was most attractive about the Sapphire system is that it has the potential to replace several different types of clinical tests into one assay. So they would be able to avoid the need to invest in additional multiple cytogenetic instruments, saving them time and streamlining their workflow. And these key sites, what Eric Homeland had stated was they're thrilled that these NHS centers have chosen to invest in optical genome mapping with the Sapphire system. He believes that their success can spark potential adoption by many other NHS testing labs across the UK. So let me know your thoughts and feelings, drop me some comments down below. Always remember, none of this is financial advice, for entertainment only, and if you'd like to support the channel, you can click the join button just over here right next to my head. You can support on any level and it really helps us to create good content. In terms of me and what I've been up to, I've been working on some Netflix series just as a background actor at the moment. In the last month, I've been on 3 Netflix series and 1 Apple TV series just in the background, trying to get some featured roles as well. Enjoying my time, and I'm going to be creating a lot of content on YouTube. Thank you guys, wishing you all the best. Mr. Invest a Lot, over and out, baby.